Section 1.2 of Intermediate Algebra covers the operations with real numbers and simplifying algebraic expressions. In this section, we're going to talk about how we add, subtract, multiply, and divide real numbers. And then we're going to look at algebraic expressions that involve those types of operations, and using some properties that those operations have, be able to simplify those algebraic expressions. We prefer to have the simplest form possible for any given algebraic expression because that means less work when it comes to evaluating those formulas and expressions. So let's get started. The essential concepts that we will cover in this section include how to find a number's absolute value, how to add, subtract, multiply, and divide real numbers. We will learn to evaluate exponential expressions. We will be using the order of operations that we learned in the earlier section. We will use commutative, associative, and distributive properties. And finally, we will simplify algebraic expressions. Before we talk about how to add or subtract real numbers, we need to talk about the absolute value of any given real number. So the absolute value of a real number A, denoted by A with two vertical bars around it, is the distance from 0 to A on the real number line. Noting that distance is positive, that means that the absolute value of a number is always positive. So for example, if we were asked to find the absolute value of -4, well, -4 is 4 units away from 0, so it is 4. The absolute value of 4.5 with no negative sign is still a distance of 4.5 from 0, so it is 4.5, also positive. In effect, all the absolute value really means in terms of finding the answer is to drop whatever sign it is and make it positive. So absolute value of a negative is positive, absolute value of a positive is positive. Okay, so it's basically ignoring the sign, thinking of it as a positive number. Now I'm going to use the term absolute value in the techniques or in the steps that we use to perform our operations on real numbers. So for example, if we're going to add real numbers, okay, here's how we do that. We basically add their absolute values, okay, in each case. But here's what we've got to remember, is that if the numbers have the same, sorry, I think what I mean here is, the same sign, have the same sign, I forgot what order I was doing this in. If we have the same sign, then we add the absolute values and keep the common sign. So if they're both negative, when you add two of them, they're going to stay negative. If they're both positive, they're going to stay positive. If the numbers have different signs, we're going to subtract the smaller absolute value from the larger absolute value, and then we keep the sign of the greater absolute value. Here are some examples for us. Take -10 plus -18. Okay, by the rule we just established, they have the same sign, so we will add their absolute values, meaning ignore the sign, take 10 plus 18, you get 28. And then you keep the common sign. They both have a negative, so it is negative. That's how we add two with the like sign. Now if they have opposite signs, like in example 2 here, we're going to subtract. We're going to take 0.9 and 0.2, subtract the 2. Right? 0.9, 0.2, subtract, you get 0.7. And you keep the sign of the larger value, the larger absolute value. 0.9 has a larger absolute value than 0.2, so the final answer is positive. Now if we need to add fractions together, remember that for adding fractions, we have to first find a common denominator and modify each fraction to have this denominator. So we're looking for the smallest number that both 5 and 2 would go into, their lowest common multiple, and then we're going to multiply by what we need to get to that common common denominator, both on top and on bottom, and then do the same thing for the second fraction. And then once they have a common denominator, we add the numerators and keep the denominator the same. Now, if we're going to add the numerators, we're going to use the same rule we just established for adding real numbers. So in this case, negative 3/5 and a 1/2, the common denominator would be 10, so I need to multiply this by 2 on top and bottom, and this by 5 on top and bottom. I end up with negative 6 over 10 plus 5 over 10. So the answer is going to be over 10. Now, negative 6 plus 5, they have opposite signs, so you subtract. 6 minus 5 is 1, and then you take the sign of the larger number, which is 6, so negative. So your final answer is negative 1/10. There are a couple of special terms that you need to know in the context of talking about these sorts of operations. We call the number 0. It has another name. It's called the additive identity. The reason it's called that is it has to do with the fact that if you add 0 to any number, it doesn't change the value of that number. It keeps the same identity, if you will, and that's according to addition operation. For a given real number a, the additive inverse is the number minus a. Okay, that's the number that if you add it to that number a, you get back to 0. So for example, if the number that I'm starting with is negative 6, what is the additive inverse? What gets me back to 0? That is, what is negative x? Negative x would be a positive 6. Right? It's the opposite sign of that number. Okay? What is negative x on this one? If x is 1/3, what do I have to add to 1/3 to get back to 0? What's the additive opposite? Right? It's negative 1/3. That is the additive inverse of 1/3. Now that's important to note because subtraction, while it seems like a completely new operation, technically subtraction is, well, there's no such thing as subtraction. All right? Subtraction is just addition in disguise. Look at this. To say a minus b really just means a plus the additive inverse of b, or a plus a negative b. Okay, so to subtract, we don't really have to learn any more rules. All we got to do is change the subtraction to addition, and then change the sign of the number being subtracted. And when we're done, we just add, using the same rule we just learned. So here we go. 6 minus 13 is 6 plus a negative 13. And according to our rules for adding, when you have different signs, you subtract their absolute value. So 13 minus 6 gives me 7. And then I keep the sign of the larger absolute value, which happens to be 13. So it's going to be negative. Okay. 4.3 minus negative 6.2. So 4.3 plus, and what's the additive inverse of negative 6.2? What's the opposite sign? Well, it's 6.2. Or you can think of this as a negative times a negative, right? Two negatives turn into a positive. But basically what's happening here is you're adding the additive inverse of 6.2. So 4.3 plus 6.2 becomes 10.5. They're both positive, so the answer is positive. Same thing here. If I have negative 9 plus the opposite sign of negative 3 is positive 3. So negative 9 plus 3. Opposite signs mean I subtract. So I get 6. And I keep the sign of the larger number. So it's negative. Okay, so those are the rules for adding and subtracting. How do we multiply? Let's look at that. Multiplication can be thought of as repeated addition or repeated subtraction. So for example, if I say 3 times 4, what I really mean, or one way of thinking of what I mean, is that that is 4 added to itself 3 times. 4 plus 4 plus 4. That's 3 4s, right? Which gives me 12. Okay? Now if I have 3 times a negative, Notice, by the way, up here they were both positive. I end up with a positive answer. If I have 3 times a negative 4, that's negative 4 added to itself 3 times. And as we know for the rule for addition, negative added to negative is going to be negative. Okay? The key word being that we're adding them together. Negative 4 plus negative 4 plus negative 4 is negative 12. So a positive times a negative gives me a negative. Now, if I take negative 3 times negative 4, that doesn't mean add them together 3 times. That means subtract them 3 times. So take a minus 4, minus a minus 4, minus a minus 4. We did that 3 times. So that's actually minus a minus makes positive. So 4 plus 4 plus 4 gives me positive 12. That is why a negative times a negative gives me a positive. So here's the rule to remember. Now it's slightly different than addition, so you're going to need to work. If it's not clear to you, you got to practice. There's a difference between adding like signs and different signs and multiplying like signs and different signs. So the product of two numbers with different signs, like we saw on the second example above, is found by multiplying their absolute values, and the answer is negative. Opposite signs give me a negative. Now the product of two numbers with the same sign, either both positive or both negative, is also found by multiplying their absolute value, but the answer is positive. Okay? So 8 times a negative 10. Remember, 8 sitting next to the parentheses means multiply. So we multiply 8 times 10 and get 80. Now, is it positive or negative? Well, because they're different signs, it's negative. What about 11/13 times negative 26? Okay, well, it's going to be 11 over 13. And here's what I generally do with fractions times numbers. Think of negative 26 as negative 26 over 1. I can multiply straight across. Actually, one step I can do in here is I can cancel a 13 out of the top and bottom, because 13 divides out of 13 and I get 1. 13 divides out of negative 26 and I get negative 2. 11 times negative 2 is 22, but it's negative because they're opposite signs, over 1 times 1, which is 1, or negative 22. Now the key trick here, or the key technique that you want to be aware of, is that whenever you multiply fractions together, you multiply their numerators together and the denominators together. I generally say that's just straight across. 11 times 26, 13 times 1, but you can divide out common factors if there are any when you're multiplying. One last note before we turn the page: the product of any number multiplied by 0 is always 0. 0 times anything is 0. One other note I want to make before we move on to talking about the next operation of the operation of division is to pay attention to signs and parentheses. Okay, that order of operations does matter. You see these two examples right here? They look very similar, right? The negative is on the inside of the parentheses here, but there are no parentheses here, which means we're going to get two different answers. Do you remember the order of operations that we've covered already? The rule that we call PEMDAS. In these examples, it's very important that you know how this is applied. Parentheses means you do what's inside the parentheses first, then we do exponents, right? Exponents of negative 10 times negative 10, that's going to be a positive because they're both negative, and you're going to get 100. So you get a positive 100 here. Now, on this one, you're going to do the exponents before you do the minus sign. The minus sign is like a multiplication. So actually all I have here is the minus sign, and then what's 10 squared? That's 10 times 10. The minus sign is not twice because it's not inside the parentheses, and I get a negative 100 here. So that's two different values, and it's important that you can see the difference between these two. When it's inside the parentheses, you repeat the minus sign. When it's outside the parentheses, or there are no parentheses, the minus sign just hangs around out front by itself. Dividing real numbers. Now, the number 1 also has another name, much like 0 was called the additive identity. The number 1 is called the multiplicative identity. Now, what does that mean? That means that 1 times anything doesn't change the value of that thing, right? So when you multiply by 1, you don't change the value. Now, to get from any number a back to 1, you multiply by what's called the multiplicative inverse. Right? You're trying to find the number that you can multiply by it and get to back to 1. Sometimes that number is also called the reciprocal. It happens to always be 1 over a. So for example, 3 is a number. Its multiplicative inverse, mi for short, would be 1/3, right? If I had 2/3, its multiplicative inverse is 3/2. It's the flip of the fraction, right? 1 over that fraction means flip the fraction. Okay. Same thing happened here. If you thought of this as 3 over 1, you just flip the fraction over to get the multiplicative inverse. Now, by definition, division, all it really means is to multiply by the multiplicative inverse. Another way to think of multiplication, the easiest way to think of it in my mind, is to think of it as the missing piece in a multiplication problem. A divided by B, much like if I were to say, just think off in your head here, I ask you to find 6 divided by 2. Right? You're asking how many ways can I divide 6 among 2 people. You're really asking 2 times what is 6? Or in general, B times what gives me A. The thing you're dividing by, called the divisor, times what gives me the dividend. Now, based on this, we can answer the question of why we can't divide by 0, right? Any number divided by 0, we run into a problem, right? Think about this. If I said, what is 5 divided by 0? Right? By this statement up here, that means the divisor, 0, times what gives me 5. Right? There's no such number. Because anything times 0 is going to give me 0. So I can't repeatedly add 0 until I get to any number. That's the reason why we can't divide by 0. So whenever you see this type of number, what you're always going to say is this is undefined. Okay? Anything divided by 0 is undefined. But division works for all other numbers. And the rule to divide is exactly the same as multiplication. When you have a quotient of 2 numbers with different signs, you divide their absolute values and the answer is negative. And when you have 2 numbers with the same sign, either both positive or both negative, you divide their absolute values, but the answer is positive. So look at these 2 examples here. 32 divided by negative 8. Right? That's 32 divided by 8, which is 4. And since they're opposite signs, the answer is negative. That's all there is to that. Okay. Now, when you want to divide negative 2/3 by negative 5/4, the rule for dividing fractions comes from this idea up here at the top that it's the same as multiplying by the reciprocal of that number. Right? That's the definition of division. So, in order to divide by 5/4, we're going to take its reciprocal, which, like we said up here, the reciprocal of 2/3 was 3/2, so the reciprocal of negative 5/4 is negative 4/5. So this is negative 2/3 times negative 4/5. Now multiply straight across. Negative 2 times negative 4 is positive 8. 3 times 5 is 15. It becomes positive because there were 2 negative fractions, and that's your final answer. So just to reiterate here, to divide by a fraction, what you do is you invert it, or flip it, and then multiply. Alright, just for repetition is the key to learning. Let's recall the order of operations. Remember, whenever you have to do something in order, you've got to, or do the mathematical operations in order, you start with parentheses, then you do exponents. I can spell exponents to try that again. Exponents. You do multiplication and division from left to right, and then you do addition and subtraction from left to right. So now we do a few more of these operations in this section. Let's talk about how we would simplify a more complicated expression such as this. Right, we start with parentheses. Is there anything inside the parentheses that I can simplify there? And inside, no, that's just the number -4. So I start with exponents. Right, I have an exponent here and I have an exponent here. So that's going to be 3 minus, and change 5 squared to 25, plus 12 divided by 2 times -4 squared is -4 times -4, which is a positive 16. So exponents are done. We've done parentheses, we've done exponents. What about multiplication and division? So from left to right, we're looking for either multiplication or division. Boom, we've got one right there. So we do it. 3 minus 25 plus, what's 12 divided by 2? It's 6. I still got another multiplication, so I'll do it. 3 minus 25 plus 6 times 16 is 96. Alright, so 3 minus 25 gives me a negative 22, because that's 3 plus a negative 25. You subtract the 2, 25 minus 3 is 22, and you take the larger number sign, so that's negative, plus 96. So again, adding opposite signs, I'm going to subtract 96 minus 22 is 74, and 96 is the bigger number, so it's positive. Okay? That's how we would evaluate that expression. Let's look at the next one. We have 4 plus 3 times -2 squared over 2 minus a -3. In the numerator, and by the way, for a fraction like this, do the whole numerator first and do the whole denominator second, or you can do them simultaneously, but the division is the last step. So start with exponents. 4 plus 3 times -4 squared is 4, divided by 2 minus, and we can do inside the parentheses first, so 6 minus 9 is -3. Now in the numerator I can do my multiplication, so I have 4 plus 12. In the denominator I'll have 2 minus a -3 is +3. So I end up with 16 divided by 5. And now for college algebra, it is just fine to leave your fractions improper. Sorry, for intermediate algebra, you do need to reduce. If you can come up with a common factor that you can divide out of top to bottom, you can do this, but you do not have to write it the old-fashioned way of actually taking 5 into 16 and getting 3 with 1 left over and writing that as a proper fraction. Leaving it as 16/5 is just fine. Now let me give you some properties that these operations have. Properties that will come in handy in simplifying algebraic expressions. The first is the commutative property. Both multiplication and addition have a commutative property. Commutative means that if I add two numbers together, it does not matter which order I add them in. 1 plus 2 is the same thing as 2 plus 1. And the same thing is true for multiplication, that order of multiplication does not matter. They commute, means they go back and forth like you would commute to work. There is an associative property. Now you know that if you're going to add a group of numbers together, say I wanted to add 1 plus 2 plus 3. Addition is a binary operation, meaning you're going to add 2 at a time. Now, associative property says that it doesn't matter if I add these two first and then these two, or if I did these two first and then add the result. Okay? That A plus B plus C is the same thing as A plus B added to c. Right? 1 plus 2 is 3, added to 3 is 6. Okay? 2 plus 3 is 5, 1 plus 5 is 6. It doesn't matter how you group them, you will get the same answer. And multiplication works the same way. It is associative, meaning you can associate different values together. There is also the distributive property that says that addition and multiplication have a property in common, or that that when they're in the same problem, a property occurs. If you have c times a plus b, you will get c times a plus c times b. Or if you have c times a minus b, you'll get c times a minus c times b. It distributes across multiplication, and it distributes across subtraction. Distributes across addition and subtraction. And it also works in reverse, right? If you have the multiplication on the right-hand side, AC plus BC. Simplifying algebraic expressions. Using those properties, we can now simplify some algebraic expressions. And in order to do that, let's first define a couple of vocabulary words here that we will use extensively throughout the course. Whenever I refer to the terms of an algebraic expression, those are the parts that are separated by addition, or in fact by subtraction, since subtraction is addition in disguise. The coefficients of a term are the numerical part, the numbers sitting out in front. So for example, if I have 7x plus 3y squared as an algebraic expression, the terms are 7x and 3y squared. Their coefficients are 7 and 3. Okay? Now, in order to simplify an algebraic expression in this section, what we want to be able to do is something called combine like terms. Meaning that if we have the same variable part with the same exponents, we can add their coefficients. If I have 3x's and 7x's, I can add them together by basically taking the x out and saying that's the same thing as 3 plus 7 all times x, or 10x. You can add like terms together. Like again means same variable with the same exponents. Okay, so right here we're asked to simplify 7x plus 12x squared plus 3x plus x squared. Notice the 7x and the 3x are like terms, so we end up with 10 of those terms, or 10x. On the other hand, 12x squared and x squared are the same term. So how many of those do we have? We have 12x squared here. How many x squareds do we have here? Right, that's understood to be a 1 out in front, so that's going to be 12 plus 1 is 13x squared. Now I cannot combine these together because they aren't like terms. That is completely simplified. On the next example, we're asked to simplify, so we're going to take the 8 and distribute it to each of these. Using that distribution rule, 8 times 2x is 16x. 8 times minus 5 would be minus 40. And then this minus 4x is still sitting there at the end. Now we can, to simplify, combine like terms. I have 16 and a minus 4x. 16 minus 4x would be 12x, and then the minus 40 is left. So that is simplified, and that is the end of section 1.2.